Zombie apocalypse.
Okay, so this time ito sa play yung konsepto ni Castigliano regarding sa computation ng deflection at saka ng mga titawag nating rotation. So this time let us apply that on beam. So be ready to be neurorized. Okay, so you notice that this is the same problem that we have solved in the topic of visual work. So let us try to evaluate if visual work and Castigliano will be of the same answer. That's our main objective for today. And secondary is to display the concept of Castigliano regarding how do we calculate deflections and rotations of a particular beam. Now, pressure rigidity are the same. Modulus of elasticity is 200 gigapascal, and as well as the moment of the inertia on the stronger axis is 1,500 times 10 to the 6. So same question, rotation and deflection. So before we continue, I hope that you have to watch first my video lecture on visual work application entitled Application of Visual Work Method Applied on Beam. So that you could compare easily if the answer of Castigliano's principle, as we are going to discuss right now, is the same answer for the same problem using visual work. That's what I recommend to the viewers or the learners. Let's have a short recall of what is the formulation that we have to use using Castigliano. Now, in Castigliano, actually, this is not zero. Ito kasing element na ito, consider lang kasi yan na isang member segment. But actually, it can be replaced by a more generic application as x sub 1 and L can be replaced as x sub 2. Dependent kasi, kung saan ka nag-consider ng mga segments. And then, na integral, actually, you can put sigma kasi pwede mo more than one segment. So, the moment multiplied by the partial differential equation, or rather, the partial derivative with respect to P, okay, then dx over EI. Okay, where EI can be constant or EI can be varying dependent on the nature. Now, let us define a little. Delta is what we call the deflection, okay? P as what we call the external force that we need to apply, and M, the moment that is applied actually on the beam, but there should be composition of a virtual load force P. Okay? And E and I is already discussed. This time, sa translational value theta or rotation, so by replacing 0 by x sub 1 and L as x sub 2, okay? Kasi pwede multiple segment, kaya to represent sigma, tsaka depende kung saan ka mag-start ng segmental cuts mo. So, the integral of m multiplied by the partial derivative of m with respect to m prime, so dx over ei. So, yung delta, I think we should replace by theta, okay? Actually, external rotation, okay? So, of the point caused by the real loads acting on the beam frame, and m will be represented by the moment force, replaced by moment force m prime. So, yan lang yung magiging difference ng dalawa. Okay? Okay, so let's start with the deflection at point A. So, pag deflection at point A, so, of course, we are in the interest of finding deflection at point A. So, therefore, you need to find point A and then put a load value P. Again, this load value P at point A, as asked by the question, can be interpreted as an upward force P or a downward force P. Depende kung saan yung guess ninyo. If you think that, let's say, if you have the beam and you applied P downward, then therefore the deflection will be also downward. Likewise, if the value P is applied upward, then we accept that the deflection will be most likely an upward deflection. Okay? So, by this, what is my particular guess on that particular point? So, pwede kang mag-assume ng patas pero naturally, if this is cantilever, this will be going down, So, whatever the condition, most likely it will be going down because of the longer span of the cantilever at 6 meters. So, but you can play along. So, it's up to you to assume. So, either way, kapag nag-negative lang naman yung value natin mamaya, just take the reverse of the direction. Okay? Kung P yung pababa, tapos nag-negative pa, it should be upward. So, deflection should be also upward. Ganun na ibig sabihin yan. So, therefore, the load force P is part of the solution in our reaction. That's why, how do we come up with these two reactions? And I want you to notice that the direction is already indicated, one upward and one downward. How did we solve for that? Note that this is for M as a function of P. No? M as a function of P. Meaning our function of our reaction will be a function also of P. Now what we did is this, you just take the statics as an advantage. So therefore, calculating reaction at seed. So this is assuming RC. Okay. So therefore, just take a moment at D. Then notice that P is a part of the system. And it looks like when you try to calculate this, so you will get positive 664 over 3 plus 5/3 over P. Meaning if these two phrases are positive, then your assumption is correct. Okay? So it is said to be okay. Now, if I perform sigma force vertical, and then I want to assume that RD is also upward, meaning I want, if my assumption is correct, then the RD that I will get should be both upward, or one of the terms in the equation is positive. Okay? However, as we calculate it, it turns out to be that both terms are indicated as negative. No, try to use your algebra here, no, and you will find out that they will be both negative, meaning it takes the opposite direction. Kasi if both are negative, then the true direction is also negative. That's the sense. Now, what if, let's say, kunwari lang, bigyan ko kayo ng konting citation dito. Let's say your RD seems to get, sample lang po ito, 112 over 3 minus 2/3 of P. How can we tell the true direction of that RD? Now, you cannot tell what is the true direction unless you try to find out what is P. So therefore, for you to continue, try to stick with your assumption. Try to stick with it, and then don't forget that you will be corrected later. No? You will be given some corrections after you find out what is a true value. So don't worry. Deflection is a function of P. Regardless of whatever terms is positive or negative, it's very important that you indicate the proper sign. Kasi yung negative, pag kinounter mo ng negative, nagiging positive. So para kino-correct na rin yung assumption. So if you get this kind of situation, or pwedeng ito yung negative, ito yung nag-positive, then you just stick with your assumption upward for the meantime. Then later you will be corrected by the true deflectional value. And then try to find out, since P and M is just only a virtual load. Don't forget that. P and M prime I mean. So let's start analyzing again the point by segment. So the same as with virtual work method, we start from AB. So we start from A, so meaning the cutting segment X, okay? Sectional distance X is running from A to B. Then I need to get a boundary segment from 0 to 3 since I started from A and then run to B, no? Yan yung boundary set niya. So therefore, as I write the equation as a function of P, I think you will consider the shaded region, and don't forget that there's a P on the system. Okay, so therefore you will get moment as negative 4x squared minus px. And then taking the partial derivative of m respect to p. So meaning, let us try to have a small review of what is partial derivative. So if you take this, negative x of course will be a constant. Other than p is a constant. So yan yung rule ng partial derivative. Kahit variable, nagiging constant sa kanya. So therefore, negative x times dp over dp, which is, we know that in calculus, it is set to 1. So therefore, the partial derivative of m with respect to p is negative x. So as simple as that. Next segment is, let's try to analyze segment BC, where the running distance is from point A, no, as we tag along with the distance x, okay, as drawn. So, okay, now, is segment BC running from 3 to 6 kasi ang kanya 3 to 6 kasi nga ang nangyari, we choose that the cutting segments from A, okay, running to B and A running to C. as denoted by the distance x. Okay? So therefore, the case would apply like negative 8x squared over 2 minus 100x minus 3 minus px. So taking into consideration yung mga moment interaction. Tandaan nyo po, no? Dito ka nag-cut ng cutting plane. So therefore, ito yung left, ito yung right. We know that in the left side, as we take a moment, clockwise is positive, counterclockwise is negative. And all of them will exhibit negative moment kasi counterclockwise yung kanya-kanyang mga rotation. Okay? So therefore, we will get this equation, negative 4x squared minus 100x over 3 upon simplification minus px. Again, performing the same, partial derivative of m with respect to p. Ang fokusan nyo na po agad dito, sino lang yung may mga p? No? So ito lang yung may p. Kasi aware kayo, no, that the derivative of a constant is 0. So all other than a p variable is a constant. So negative 4x squared and 100x minus 3 is considered constant here due to the fact that we are using partial differentiation. So therefore, just like what happened here, no, dito sa nauna, since negative 4x squared is a constant, so therefore the derivative of such is 0. Kasi p is just only the main variable in question. So this time, no, try naman natin yung CD. Pero kung napapasin yung setup natin is pa kanan. Action distance natin dati, if you will review our video lecture on visual work method, and then we transcribe this as 15 minus x. And then, ginawa natin, dalawang triangle, ano? So, pasin nyo, ang daming load eh. So, running from 6 to 15 ang nangyari. Pero teka, mas maraming load yon. At yun lang ba yung way? Natandaan po ninyo, pag nagkakaroon tayo ng cutting portion, lagi pong dalawa ang nagkakaroon ng isolation. Okay? Left and right. Yung ginagawa natin lagi, no last discussion is laging nasa left. Pero tandaan nyo, pwede namang right. Sige, tingnan natin left and right. Tinuro sa statics, kapag ang moment sa left, clockwise, positive. Kapag counter is negative. On the right, nire-reverse po natin yan, right? Alam nyo po kung anong reason? It is the condition, okay, of deflection, okay? Let me draw a little. Paano nangyari yan? Sabi kasi ng deflection rule, kapag meron kang positive bending, pababa ang deflection. Okay? Pag nagpas ka ng cutting plane dyan, ang clock, ganito pang bending rule. So, positive dito, positive yan. Okay? Kapag negative naman, bending, okay? So, pataas po yung deflection. Don't forget, ito yung left and yung right, ano? So, left and right. So, gano'n naman po yung bending rule. Okay? Yan. Ito yung mga negative movement. So, therefore, ito po yung primary reason bakit sa statics, itinuturo na yung rotation ng counter yung negative sa kaliwa, pero pagdating sa kanan, siya yung nagiging positive. It is because of the deflection. So, noting that, no? So, we will have from 0 to 9. Kasi tandaan nyo, nanggaling na tayo sa D. Pumunta tayo ng papuntang C, or wala pang C. So, therefore, ang kanyang attraction is from right to left. So, therefore, right cut portion prevails. So, you need to find out. Kasi pag ito, exaggerate natin, may triangle ka, no? You need to find y as a function of x. So, x na ito. Y 0 to 9. Nanggaling ka sa D, papuntang C. Okay? Hindi ka nanggaling ng A para sabihin 6 to 15. It should be only 0 to 9. So, therefore, by that, we can derive y as a function of x equals y is equal to 8x over 9. And then performing the calculation for moment, okay? So you can now get this following equation. What we did is, we consider this downward load. So therefore, ang ikot po niya is clockwise. So that's why there is a negative sign here times the distance of x, okay? And then another clockwise rotation of this triangle, okay? So therefore, what we get is, again, negative, then performing the area of a triangle multiplied by the centered x-third, so 1/3 of x. So we'll find out that m is negative, upon simplification, negative 112x over 3 minus 2/3 of px minus 4 over 27x cubed. Again, doing partial derivative, what you can notice that the negative 112 over x over 3 and the negative 4 over 27x cubed will be a constant to our solution. Even though there is an x, kasi don't forget, no, partial derivative with respect to p. So therefore, it only recognizes that p is our independent variable. So by that, so P will be considered variable for integration or for partial differentiation. So therefore, negative 2/3 times x will be a constant, okay? And then partial derivative of P with respect to P is 1. So that's why the partial derivative of M with respect to P is negative 2/3 of x as we obtained here. Okay. So therefore, using these three derived partial derivative values, so let us try to implement the use of Castigliano. Okay? Implementation like this, so as mentioned earlier. But if you want to proceed using Castigliano, don't forget to set P as 0. Why set P 0? Don't forget that P is a virtual value. So it really does not exist on the system as a real load. Since deflection is real, not virtual. So therefore, since EI is set to be a constant here, so or a prismatic member, meaning EI is considered consistent throughout. So therefore, we can safely say that EI can be factored. So 1 over EI is being factored. But in the event that there's a field of doubt, then you have to divide it separately by their respective EI. Let's say EI of the segment 1, EI of the segment 2, just in case, EI of the segment 3. So do it separately. But here does not apply since EI is just only a single value. So it represents throughout the length of the particular beam. So performing the same using the correct segment limits, okay, notice, so they're being multiplied M like this times the partial derivative of M respect to M. Likewise here, and this one also. You will notice that they will produce these three constant simultaneously. So this is also the same value that you can get using visual work as I displayed that on my past video lecture with the title of Application of Visual Work Method Applied on Beam. So if you want, you can go back to that particular discussion and then to verify if we got the same answer. So therefore, again, I explained that how did we arrive to a unit of kilonewton cubic meter. And then following the conversion into newtons and millimeters, so implementing the factor of 1,000 to the fourth, converting kilonewton to newton, a 1,000 value, and a cubic meter to a cubic millimeter of a value 1,000 cube, making it 1,000 to the fourth. So we'll get 8967 over 250 mm. And it looks like it turns out to be positive value. So therefore, our assumption is correct. And it goes down. Okay? Sabi nga po sa inyo, kung anong direction ng visual load P is also the direction of the deflection. So therefore, it is very important to denote the proper direction, also known as the true value and the true direction. And if rounded up, it is 35.868 millimeters. So it's almost 1.5 inch. Okay? So that's the final answer for the deflection at point A. Now let's move on rotation. Now finding point A and applying rotation. So therefore you need to apply a moment M prime. It can be a counter, it can be a clock. Ganito na lang po siguro. Basta pagka nag-apply kayo ng counter sa dulong-dulo, it means you're allowing that the bending should go down. Okay? So ganun ang rule. So it will tip it will rotate this tip into a downward location. Ganun din po yan. So parang ganito rin, no? Pag nag-attempt kayo ng pag ganito, okay? So there should be an equivalent deflection. Is it upward or downward? Try to simulate. You go back to the discussion earlier. So it has something to do with the deflection. So ganito, pag tumama yung rotation, meaning tama yung ating assumption ng ikot niya. Okay? Now, so therefore, I assume that the rotation is counted because on the tip, it looks like the tip will go down. So therefore, I need to apply. But anyway, kapag kinlockwise mo, tag-negative, same value lang din naman lalabas, but it will tell you to correct your rotation. Okay? That's it. Yun lang naman ang pinaka-sense niya. And then, finding for this reaction, okay, how do we derive that? Using again statics. So, you found out it will have this R sub C. Ito po yung ating R sub C. Ito po yung ating R sub D. Okay, notice that in the R sub C, inassume kong upward, nag-positive, sabihin okay. But yung R sub D natin, inassume ko upward, but both of the terms is negative. So, meaning there's no way for this to go up. So, if I take the reverse direction, making it both positive, and then it is a downward location. So, ganun din po. Pag sinabi kong, kunwari, RD, nakuha nyo. Sample lang, no? Negative 112 over 3 plus M prime over 9. You can never tell, no? Kung sa ano yung direction ito, unless you know what's M prime. So, therefore, dahil nag-assume ka na upward, iligay mo upward. Para sa rotation, alam mo kung ano yung dapat mo i-consider. Okay? And then, using statics will do the trick. Okay? So, this time, no, we apply this. AB, ganun po ulit kanina, similar na sa nauna natin. So, you'll find out that this is the value. So, negative 4x squared minus m prime as we take the moment at A, no, at cut segment AB with the limit segment 0 to 3. So, negative 1 po yung partial derivative of m respect to m prime. Why? Wala pong katabi yung negative m prime, no? So, therefore, para negative partial derivative of m respect to m prime, so this is just only 1. So, 1 times negative, 1 is negative 1. So, likewise, on BC, you will get this formulation in terms of m prime. And again, negative 4x squared and negative 100x over minus 3 looks like a constant when we try to take a partial derivative with respect to m prime. So therefore, we'll get negative 1 again. Okay. And then doing the same on segment CD, so you found out that m prime x over 9 with a negative sign will be only the phrase or term to investigate for partial differentiation, which means negative 112x over 3 and then the negative 4 over 27x cubed is a constant here since m prime is the main independent variable. Okay, so therefore we got negative x over 9. So this time, using these equations, no, the m and the partial derivative of m with respect to m prime compilations. So again, doing the same. So for the rotation, and then don't forget again to set m prime to 0. But the main reason, since m prime is a virtual value again, m prime is not really existing to the system. So therefore, you will get 36 plus 702 plus 6012 over 5, meaning the assumption is correct na nag-positive, meaning tama yung assumption natin na bababa nga yung deflection. Kasi ititipol siya pababa nung moment na counterclockwise. So therefore, this positive 9702 over 15 displays the same answer using visual work method. Again, kindly review our video lecture entitled Application of Visual Work Method, no, on beams. So again, same explanation on what particular quadrant does theta A is being included. So, magiging quadrant, ano lang po ito, no? 1 and 3. Okay? So, I explained already why on that particular video lecture. So, because nagbababa siyang ganyan, proven na bumaba ang deflection. Okay? So, ito yung deflection. So, therefore, nandito siya sa quadrant 1 or 3. And the final answer is 6.468 times 10 to the negative 3 radian. Pero kung i-convert nyo sa degrees ito, madali lang. So, alam nyo na yung ratio niyan. That is 180 over pi if you want to find out in terms of degrees. But the default unit is, of course, radians. So, that's it. No? Thanks for viewing. I hope you learned something new today regarding Castigliano. Next topic would be application of Castigliano's principle on trusses. Okay? So, don't forget to hit the like and share button below. So, again, our very own tradition, you have been neurorized, and I hope to see you in our next video lecture. So, okay?